The term multiverse refers to the idea that there may be multiple, possibly infinite universes that exist beyond our observable universe. Each of these universes may have its own set of physical laws, constants, and conditions. The concept of a multiverse has emerged from various scientific theories and speculative ideas in cosmology and theoretical physics. Now take a deep breath and relax. I'm going to explain you guys each and everything about multiverse in this video. The concept of the multiverse holds significant importance in both science fiction and scientific speculation, captivating the imagination of scientists, writers, and enthusiasts alike. Here are some key aspects that highlight the significance of the multiverse concept. Expanding human understanding. The idea of a multiverse challenges our traditional understanding of the cosmos and pushes the boundaries of human knowledge. It encourages us to think beyond the limits of our observable universe and consider the possibility of other realms or dimensions. Infinite possibilities. The multiverse hypothesis suggests that there could be an infinite number of universes, each with its own set of physical laws and conditions. This notion opens up a vast landscape of possibilities, allowing for diverse and sometimes fantastical scenarios that capture the imagination. Inspiration for science fiction. Science fiction writers have been drawn to the multiverse concept for decades because of its potential for creating complex and unique storylines. Alternate realities, parallel universes, and the exploration of different timelines provide fertile ground for creative storytelling and imaginative exploration. Diverse storytelling opportunities. The multiverse allows storytellers to explore a wide range of scenarios, from worlds where history unfolded differently to places with entirely alien physics. This diversity enables the creation of compelling narratives that challenge characters and audiences alike. Philosophical implications. The concept of the multiverse raises profound philosophical questions about the nature of existence, reality, and our place in the cosmos. It prompts contemplation of topics such as the anthropic principle, the role of consciousness, and the meaning of our existence within a vast and potentially infinite multiverse. Scientific speculation and exploration. In scientific circles, the multiverse is a topic of speculation and exploration. While not universally accepted, it has become an intriguing aspect of theoretical physics and cosmology. Scientists explore the implications of different multiverse hypotheses to better understand the fundamental nature of our universe. Addressing fine-tuning and coincidences. The multiverse concept has been proposed as a potential solution to the fine-tuning problem in cosmology. Some argue that if there are countless universes with varying physical constants, the apparent fine-tuning of our universe for life becomes less surprising. Ongoing scientific debate. The idea of a multiverse is still a subject of active scientific debate. Researchers are exploring ways to test or validate different multiverse hypotheses, making it an exciting and evolving area of study within the scientific community. Several diverse theories and frameworks in physics contribute to the idea of a multiverse. Each of these theories proposes different mechanisms or scenarios that could give rise to multiple universes. Here are some of the key contributors to the multiverse concept. Inflationary cosmology. Description. Inflationary cosmology suggests that the early universe underwent a rapid and exponential expansion shortly after the Big Bang. This expansion could lead to the formation of pocket or bubble universes within a larger inflating space. Contribution to the multiverse. The inflationary multiverse hypothesis proposes that our observable universe is just one of many regions within a continuously inflating space, with each region having potentially different physical properties. Many worlds interpretation of quantum mechanics. Description: the many worlds. Interpretation suggests that every quantum event with multiple possible outcomes results in the creation of multiple parallel universes. Each universe represents one of the possible outcomes of the quantum event. Contribution to the multiverse. This interpretation implies a vast ensemble of parallel universes, each representing a different outcome of quantum events. It contributes to the idea of a quantum multiverse. String theory and brane worlds. Description. String theory is a theoretical framework that describes fundamental particles as tiny, vibrating strings. In the context of string theory, brane worlds propose that our observable universe is a three-dimensional membrane, brane, embedded in a higher dimensional space. Contribution to the multiverse. The idea of brane worlds suggests the possibility of multiple branes existing in the higher dimensional space, each representing a different universe. Collisions or interactions between these branes could give rise to the multiverse. Anthropic principle. Description. The anthropic principle is a philosophical and cosmological concept that suggests our observations of the universe are constrained by the requirement for the existence of conscious observers. Contribution to the multiverse. The multiverse is invoked to explain why our universe appears finely tuned for the existence of life. If there are many universes with different properties, the anthropic principle becomes a natural consequence. Parallel universes. Description. The concept of parallel universes proposes the existence of multiple, separate universes that coexist alongside our own. These universes may have similar or different physical laws and constants. Contribution to the multiverse. Parallel universes contribute to the idea that our universe is just one of many, and variations in physical laws or conditions could exist in these parallel realms. Cosmic bubble collisions. Description. Some models of the multiverse suggest that collisions between cosmic bubbles, regions of space with different properties, could lead to the creation of new universes. Contribution to the multiverse. The idea that collisions between cosmic bubbles could spawn new universes adds another layer to the multiverse hypothesis. These diverse theories and frameworks collectively contribute to the richness and complexity of the multiverse concept, providing different avenues for exploring the possibility of multiple universes beyond our own. It's important to note that while these ideas are fascinating, the existence of a multiverse remains a topic of ongoing research and debate within the scientific community. Cosmology is the scientific study of the large-scale structure, origin, evolution, and eventual fate of the universe. It involves understanding the fundamental nature of space, time, matter, and energy on cosmic scales. Here are some basic concepts of cosmology and an overview of the structure of our observable universe. Big Bang Theory. Concept. The Big Bang Theory is the prevailing cosmological model that describes the origin of the universe. It posits that the universe began as an extremely hot and dense state around 13.8 billion years ago and has been expanding ever since. Key points. The universe started from an incredibly small and dense singularity. It has been expanding and cooling, leading to the formation of galaxies and other cosmic structures. Cosmic microwave background, CMB. Concept. The cosmic microwave background is the afterglow of the Big Bang, a faint radiation that permeates the entire universe. It provides crucial information about the early conditions and evolution of the cosmos. Key points. The CMB is a remnant of the hot, dense state of the early universe. It is nearly uniform, but contains small temperature variations that reflect the seeds of cosmic structures. Large-scale structure. Concept. The large-scale structure of the universe refers to the distribution of galaxies, galaxy clusters, and other cosmic structures on vast scales. Key points. Galaxies are organized into clusters, superclusters, filaments, and voids. Gravity plays a key role in shaping the large-scale structure. Dark matter. Concept. Dark matter is a mysterious form of matter that does not emit, absorb, or reflect light. It outweighs visible matter and exerts gravitational influence, contributing to the structure of the universe. Key points. Dark matter interacts gravitationally with normal matter and helps in the formation of galaxies and galaxy clusters. Its nature remains unknown and is an active area of research. Dark energy. Concept. Dark energy is a form of energy that is thought to drive the accelerated expansion of the universe. Key points. Dark energy is believed to counteract gravity, causing the expansion of the universe to accelerate. It represents a significant portion of the total energy density of the universe. Observable universe. Concept. The observable universe is the part of the entire universe that we can see and detect with our telescopes and instruments. Key points. Due to the finite speed of light and the age of the universe, we can only observe a portion of the cosmos within our cosmic horizon. The observable universe is estimated to be about 93 billion light-years in diameter. Expansion of the universe. Concept. The universe is not static. It is expanding. Galaxies are moving away from each other, and the rate of expansion is accelerating. Key points. Edwin Hubble's observations in the early 20th century provided evidence for the expansion of the universe. The accelerating expansion is attributed to dark energy. Understanding these basic concepts provides a foundation for exploring more advanced topics in cosmology, including the multiverse hypothesis, the fate of the universe, and the nature of dark matter and dark energy. The field of cosmology continues to evolve as scientists make new observations and refine our understanding of the cosmos. Inflationary cosmology is a theoretical framework that proposes a brief exponential expansion of the early universe, occurring within a tiny fraction of a second after the Big Bang. This period of rapid expansion, known as cosmic inflation, was first proposed by physicist Alan Guth in the 1980s to address certain problems and observations in standard Big Bang cosmology. Inflationary cosmology has become a key component of our understanding of the early universe, and it also plays a role in the development of the multiverse hypothesis. Here's an introduction to inflationary cosmology and how it leads to the idea of a multiverse. Cosmic inflation. Concept. Inflation proposes that the universe underwent an exponential expansion, much faster than the speed of light, during the first moments after the Big Bang. Key points. Inflationary expansion smoothed out the initial irregularities and produced a remarkably homogeneous and isotropic universe. It explains the observed large-scale structure of the cosmos, such as the uniform temperature of the cosmic microwave background, CMB, radiation. Inflationary potential. Concept. Inflation is often associated with a scalar field, inflaton field, that is responsible for driving the rapid expansion. Key points. The potential energy associated with the inflaton field is responsible for driving the inflationary expansion. As the inflaton field evolves, it undergoes a phase transition, leading to the release of energy that drives the exponential expansion. End of inflation. Concept. Inflation doesn't last indefinitely. The inflation field eventually reaches a stable state or undergoes a phase transition, causing inflation to end. Key points. The end of inflation results in the reheating of the universe, where the energy stored in the inflation field is converted into particles, initiating the hot Big Bang phase. Quantum fluctuations. Concept. During the inflationary phase, quantum fluctuations in the inflation field lead to density fluctuations in the early universe. Key points. These density fluctuations serve as the seeds for the formation of cosmic structures like galaxies and galaxy clusters. Quantum fluctuations imprinted during inflation are responsible for the observed temperature variations in the CMB. Inflationary multiverse. Concept. The key idea connecting inflationary cosmology to the multiverse hypothesis is that inflation may not occur uniformly throughout space. Key points. Quantum fluctuations during inflation can lead to different regions of space experiencing slightly different inflationary stories. This variability results in the formation of pocket, or bubbly universes within a larger, inflating space. Eternal inflation concept. In some inflationary models, inflation can be eternal, meaning that certain regions of space continue to inflate while others exit inflation and form observable universes. Key points. This ongoing process gives rise to an ensemble of regions with different physical properties, effectively creating a multiverse. Inflationary cosmology provides a mechanism to explain the large-scale structure and homogeneity of our observable universe. When inflation is considered in a broader context, accounting for potential variations in its dynamics, it leads to the idea of a multiverse with diverse regions or pocket universes, each with its own set of physical laws and conditions. The multiverse hypothesis within the framework of inflationary cosmology is a fascinating avenue that continues to be explored and studied in the field of theoretical physics. The multiverse hypothesis is influenced by certain key concepts from quantum mechanics and string theory, two fundamental frameworks in physics. While these concepts are speculative and not universally accepted, they contribute to the idea that our universe might be one of many, within a larger multiverse. Here are some key concepts from quantum mechanics and string theory that play a role in the development of the multiverse hypothesis. Quantum mechanics. Many worlds interpretation, MWI. Concept. The many worlds interpretation suggests that every quantum event with multiple possible outcomes leads to the creation of multiple parallel universes, each realizing one of the possible outcomes. Contribution to the multiverse. MWI implies a branching structure of reality, where every conceivable outcome of quantum events occurs in a separate universe. This contributes to the idea of a vast multiverse encompassing all possible quantum states. Quantum fluctuations concept. Quantum mechanics allows for the existence of short-lived fluctuations in the energy of empty space, known as quantum fluctuations. Contribution to the multiverse. In the context of inflationary cosmology, quantum fluctuations during the inflationary period may lead to the formation of different regions with distinct physical properties, contributing to the multiverse. Anthropic principle. Concept. The anthropic principle suggests that the observed properties of the universe are compatible with the existence of intelligent observers. Contribution to the multiverse. In a multiverse scenario, where different regions have different physical constants and laws, the anthropic principle is invoked to explain why our universe has conditions suitable for life, as observers can only exist in regions compatible with their existence. String theory. Landscape of vacua. Concept. String theory proposes that the fundamental building blocks of the universe are tiny, vibrating strings. It predicts a vast landscape of possible vacuum states or solutions, each representing a different set of physical laws and constants. Contribution to the multiverse. The landscape of vacua in string theory provides a natural framework for the existence of a multiverse. Different regions of this landscape could correspond to different universes with varied properties. Brane worlds. Concept. In string theory, a brane is a multidimensional object that can exist in higher dimensional space. Our observable universe could be a three-dimensional brane floating in a higher dimensional space. Contribution to the multiverse. If there are multiple branes in higher dimensional space, each representing a different universe, interactions or collisions between these branes could give rise to the multiverse. Eternal inflation in string theory. Concept. Some versions of string theory predict eternal inflation, where certain regions of space continue to inflate while others exit inflation and form observable universes. Contribution to the multiverse. Eternal inflation in the context of string theory can lead to the creation of diverse universes with different physical properties, contributing to the multiverse. Holographic principle. Concept. The holographic principle suggests that the information content of a three-dimensional region can be encoded on its two-dimensional boundary. Contribution to the multiverse. The holographic principle is explored in the context of the AD-CFT correspondence in string theory. It provides insights into the nature of space, time, and quantum gravity in a manner relevant to the multiverse hypothesis. The multiverse hypothesis is informed by the speculative yet intriguing concepts within quantum mechanics, such as the many worlds interpretation and quantum fluctuations, as well as the rich landscape of vacua, brane worlds, and eternal inflation in string theory. While these ideas remain speculative and face ongoing scrutiny, they contribute to the exploration of the possibility that our universe is just one among many within a broader multiverse. If multiverse is real, how would we detect other universes? As of now, the question of how to detect or observe other universes in a multiverse, if it exists, remains highly speculative, and there are no established methods or technologies for such observations. The multiverse hypothesis poses significant challenges to detection, as the potential other universes might have different physical laws, structures, or exist in higher dimensional spaces. Here are some speculative ideas that scientists have considered, although it's essential to note that these concepts are highly theoretical and face numerous practical challenges. Cosmic microwave background, CMB. Anomalies. Anomalies or irregularities in the cosmic microwave background radiation, the afterglow of the Big Bang, could potentially indicate interactions with other universes. Advanced instruments capable of precise measurements and data analysis techniques would be necessary to detect and interpret such anomalies. Gravitational effects. Gravitational interactions between our universe and other universes might leave observable imprints. Detection methods could involve advanced gravitational wave detectors, which are sensitive to cosmic events, or the study of specific lensing patterns in the light from distant objects. Bubble collisions. In scenarios where universes form as bubbles in an inflating space, collisions between these bubbles could leave distinctive patterns in the large-scale structure of the cosmos. Observing and interpreting such patterns would require advanced astronomical surveys and data analysis techniques. Particle signatures. The presence of other universes could potentially influence particle behavior in our universe, leading to unique signatures. Detecting these signatures might involve experiments at high-energy particle accelerators or the study of cosmic ray data. Effects on the cosmic microwave background, CMB, polarization. Some theories propose that interactions with other universes could imprint specific polarization patterns on the CMB. Future space-based observatories designed to measure CMB polarization with unprecedented precision could be crucial for such detections. Exotic cosmic structures. The large-scale structure of the universe, such as the distribution of galaxies and cosmic voids, might exhibit patterns influenced by interactions with other universes. Analyzing these cosmic structures in detail might provide indirect evidence. It's important to emphasize that these ideas are speculative, and the feasibility of detecting other universes is still a topic of ongoing theoretical research. The challenges include the vast distances between universes, the potential existence of higher dimensional spaces, and the difficulty of distinguishing signals from other universes from those originating within our own. As technology advances and observational techniques improve, new methods may be proposed and tested, but, as of now, direct observational evidence for the existence of a multiverse remains elusive. Certainly, if we entertain the hypothetical notion that the multiverse is real, it introduces a fascinating landscape of infinite possibilities. In this speculative framework, each universe within the multiverse could boast its own distinct set of physical laws, constants, and cosmic conditions, leading to an unparalleled diversity of realities. The concept suggests that every conceivable quantum outcome and decision could give rise to a new universe, unfolding alternate histories and branching timelines. The multiverse might offer an explanation for the finely tuned nature of our universe, invoking the anthropic principle to argue that the conditions favor the emergence of life. Such a vast cosmic ensemble could exhibit convergence, with certain universes sharing similarities or interconnected features. If parallel realities exist, individuals might simultaneously experience variations of their lives in different universes. The hypothetical navigation or traversal between these universes could potentially open the door to unprecedented exploration and interactions, adding a layer of complexity and wonder to our understanding of the cosmos. It's important to note that these reflections are speculative and imaginative, representing possibilities within the conceptual framework of a multiverse. If we speculate on the existence of a multiverse and consider the diversity of conditions across different universes, it leads to intriguing possibilities for how human life might unfold in alternate realities. Here are a few speculative examples. Diverse civilizations. In one universe, the development of human civilizations might have taken a dramatically different course, resulting in societies with alternative technologies, cultural norms, and societal structures. The range of possibilities could be vast, from advanced technological utopias to radically different social systems. Alternate histories. Different universes might represent variations in historical events. Choices made by individuals or societies could lead to entirely different geopolitical landscapes, historical figures, and cultural movements. For example, pivotal decisions in war or diplomacy might have divergent outcomes, shaping alternative historical narratives. Different laws of physics. If each universe has its own set of physical laws, humans might exist in universes with different fundamental constants. This could impact the nature of matter, energy, and the possibilities for technological advancements. For instance, in a universe with altered physics, the development of entirely different technologies might be possible. Varying biological forms. The conditions for life might differ across universes, leading to the evolution of humans with different biological characteristics. Life forms could adapt to diverse environments, resulting in a wide array of physical and physiological traits. Parallel realities and choices. If the many worlds interpretation holds true, every decision made by an individual could spawn a new universe with a different outcome. Humans might lead simultaneous existences across parallel realities, experiencing varied life paths based on their choices. Interaction with alien civilizations. In some universes, the conditions for life might be such that intelligent extraterrestrial civilizations coexist with humanity. Interactions with these alien species could be a common and integral part of human existence in those universes. Quantum entanglement consequences. If the multiverse involves interconnected quantum states, humans might experience phenomena related to quantum entanglement across universes. Events in one universe might have correlated effects in another, leading to novel and potentially mysterious consequences. It's important to emphasize that these examples are purely speculative and rooted in imaginative exploration of the concept of a multiverse. The actual nature of a multiverse, if it exists, and its impact on human life, remain open questions in the realms of theoretical physics and philosophy. The concept that the universe is expanding refers to the idea that the distances between galaxies and galaxy clusters are increasing over time. It's important to clarify that when scientists say the universe is expanding, they are not necessarily referring to an increase in size within a pre-existing space, as one might imagine inflating a balloon. Instead, it means that the spatial distances between galaxies are getting larger. The idea of an expanding universe is a key prediction of the Big Bang theory. The evidence for this expansion comes from observations of distant galaxies. Edwin Hubble in the 1920s observed that galaxies are moving away from us, and the more distant a galaxy is, the faster it appears to be receding. This observation led to the formulation of Hubble's law, which describes the relationship between the distance to a galaxy and its apparent recession velocity. Now, when we say the universe is expanding, it doesn't necessarily mean there's an edge that's moving outward into pre-existing space. Instead, The expansion is a change in the distances between objects in space. This concept can be challenging to visualize, especially when we think of infinity. Here's a helpful analogy. Imagine a uniformly dotted balloon. As the balloon inflates, every dot on the balloon moves away from every other dot. No matter which dot you're on, you see all the other dots moving away from you. Importantly, there is no center to the expansion, and the surface of the balloon represents the universe. In this analogy, the two-dimensional surface of the balloon is analogous to the three-dimensional space of our universe. Now, regarding the idea of an infinite universe, the current understanding based on cosmological observations, including the cosmic microwave background radiation, suggests that the universe could be spatially infinite or very close to it. This notion of spatial infinity doesn't conflict with the idea of an expanding universe. Even in an infinite universe, the expansion refers to the changing distances between galaxies over time, rather than a change in the overall size of the infinite expanse. The relationship between the existence of a multiverse and the possibility of time travel is a complex and speculative topic. The theoretical framework that connects multiverse concepts with time travel often involves exploring the implications of various physical theories, including general relativity and quantum mechanics. Here are a few considerations. Many worlds interpretation, MWI. In the context of the many worlds interpretation, MWI, of quantum mechanics, the idea is that every quantum event with multiple possible outcomes leads to the creation of parallel universes, each realizing a different outcome. While MWI doesn't inherently involve time travel, the existence of parallel realities might be conceptually linked to the idea of alternative timelines, wormholes, and general relativity. Some theories that allow for the possibility of time travel, such as traversable wormholes, are derived from solutions to Einstein's field equations in general relativity. If the multiverse has structures or connections that allow for traversable wormholes, it might open the door to the potential for time travel between different universes. Temporal divergence in parallel universes. If time travel is possible within a single universe, it might have consequences for the nature of time in parallel universes. The concept of temporal divergence suggests that the actions taken in one universe could influence the timelines of connected or parallel universes. Quantum entanglement. The concept of quantum entanglement, which involves a correlation between particles regardless of distance, has been explored in the context of potential connections across universes. If such entanglement exists between particles in different universes, it could have implications for the nature of time and causality. It's crucial to note that these ideas are highly speculative, and the scientific understanding of time travel, let alone its connection to a multiverse, is still a subject of active research and theoretical exploration. Additionally, the feasibility of time travel involves addressing numerous challenges, including issues related to causality, energy requirements, and the stability of any potential time travel mechanisms. The discussion of time travel within the context of a multiverse remains speculative and theoretical, and there is currently no experimental or observational evidence supporting the existence of a multiverse or demonstrating the practicality of time travel. The concept of a multiverse, particularly in the context of the many worlds interpretation MWI of quantum mechanics, suggests that every possible outcome of a quantum event leads to the creation of a parallel universe. In this framework, if the multiverse is real, it could imply the existence of multiple versions of you, each experiencing a different outcome or path of events. According to the MWI, every decision or quantum event that has multiple possible outcomes results in the creation of separate branches of reality, each realizing one of the potential outcomes. This leads to the idea that there are countless parallel universes, each representing a different configuration of reality. In these parallel universes, there might be versions of you that made different choices, took different paths in life, or experienced different events. These alternate versions could coexist simultaneously in their respective universes, forming a vast ensemble of parallel realities. It's important to note that the idea of multiple versions of oneself is a speculative and theoretical concept within the framework of the multiverse hypothesis. The existence of a multiverse is still a topic of scientific investigation and debate, and there is currently no direct observational evidence confirming its reality. The implications of a multiverse, including the existence of alternate versions of individuals, remain speculative and open to interpretation within the realm of theoretical physics.